Okay, so now we get three equations. The coefficients of x squared have to be equal, so C2 equals A, C3 equals B, and C1 minus C3 equals C. That's three equations and three unknowns, right?
Wouldn't it be C1 plus C2 minus C3?
Maybe. I've got an, oh wait, I've got an X here, right? I missed that. Thought there was more. No, wait, hold. There's an X minus 1 there, there's an X. Okay. It's X and X minus X squared plus 1, X minus 1. Not sure I'm wrong. Because we only have one X squared, that's C2, right?
Right.
But I have a rash of mistakes today, so let's be sure I'm overlooking stuff. C3X. The only X I have is this one.
Right. But
Oh
you
yeah,
have
you're
three
saying there
ones.
should be C2 here.
Yeah. Right.
Okay. Yes, you're right, I missed that. So let's. Okay. So now we have pretty much what I had before, except the last equation is equals, yeah, C. Okay? Now we can easily solve those equations, but in general, we're going to really want to use a matrix. Okay? This one's simple enough that it's easy to solve without the matrix. I'm going to try to illustrate what we do in all cases, in the general case, so we want to write this as a matrix equation. So okay? And to put that in the form of a matrix equation, C2 equals A, okay? So our first row would be 0, 1, 0. That gives us C2, and that's going to have to equal A, right? Okay? And then C3 equals B, so that 0, 0, 1 gives us C3, and that's got to be equal to B, right? And then we have C1 plus C2 minus C3. It's going to give us 1, 1, negative 1 times C1, C2, 3, C3, and that's got to going to equal C, right? So this matrix gives us a transition, okay? So if I want to know what the C1, C2, C3 are, I multiply this matrix by the inverse of this one. Now that only works if these rows are independent, which means it only works if the columns are independent, which means, and you want to think about this, it only works if these three vectors are linearly independent. Okay? So you can test linear independence by seeing whether the determinant of this thing is 0 or not. Okay, well, the only row you have here gives you non-zero is this one, right? You're going to have this times this times this, and that's the only number you're going to have. It's either going to be positive or negative, and you don't even have to think it through, but it's not a bad idea. Okay? And so your determinant's either going to be 1 or -1. You don't have to reduce the matrix or anything, but often you would. And you would want to reduce it to invert it maybe. Because in order to get this, you got to invert it. Okay? So, I'm just going to say check invertibility. Which is equivalent to linear independence of the basis. So if this really is a basis, it's guaranteed, right? And you get this. Okay? And this is the expression of the ABC vector relative to this basis. So that AX squared plus BX plus C I don't even want to say it's identified with the ABC. I think that's going to be confusing. Okay. This thing is equal to the inverse times this relative to the basis B. Okay? Now, how would you express V1, V2, and V3 in terms of basis B? In other words, the basis vectors in your B tilde basis. Okay? Expressed in terms of the B basis. You know, write the numbers in here.